Okay, good morning, everyone. As usual, questions before we get going. I give you a minute to gather your thought. Okay. So we start. So we're talking about power series, which is, as I mentioned yesterday, those are like polynomial with infinite degree. So it's a generalized idea of a polynomial. So it's a series that looks like a polynomial. And our interest for the moment is to find, so the series depend on a variable x, and our interest is to find for which value of x does the series actually converge. So we will look at the problem that your classmate is asking. Number 16. Okay. So we have the following series, sigma from 0 to infinity of -1 to decay over 5 to decay. Okay, and the question is, for which values of x? So as you realize, there is an x in here, so x can change. As x can change, for some of them the series converge, and for some it will diverge. And the question is which x's it will converge. Right, so we use the ratio test. Okay, so what does the ratio test tells me? Tell me that we're gonna take, so the general term is -1 to decay, x to decay, 5 to decay. So definitely there is an x in here, that is a variable. And the terms that follow is -1 to decay plus 1, x to decay plus 1 over 5 to decay plus 1. And we have to compute the ratio, and the ratio in absolute value, because the terms are not positive. So we're going to take the absolute value of ak plus 1 over the absolute value of ak. So this will give me the following. This will give me the limit as k goes to infinity of. The numerator is -1 to decay plus 1 times x to decay plus 1 over 5 to decay plus 1. And the denominator is -1 to decay, x to decay over 5 to decay. Okay, so now we have to compute this ratio. Now, let's look what happening with the absolute value. These terms, the -1 to decay, when you take the absolute value, it will go away. So because every minuses, the absolute value will absorb. 5 to decay plus 1 is positive. X to decay plus 1, when you take the absolute value, so this is going to become the following. The absolute value of x to decay plus 1 over 5 to decay plus 1. Because as I mentioned yesterday, and I mentioned this for the last time, when the absolute value can be split. So if you have absolute value of A times B, you can split it, absolute value of A times, and it has to be multiplication here. And if you have the absolute value of A over B, is the absolute value of A, the absolute value of B. So we have those properties. And that's exactly what I'm doing here. -1 to decay plus 1 times this. So this is multiplied. So I split. It's my absolute value of that, which is 1, times the absolute value of this. And then I say, okay, the absolute value has the property is the numerator over the denominator. So I took the absolute value of the numerator divided by the absolute value of the denominator, which is a positive number. I can get rid of it. I do the same here. I will have x to decay over 5 to decay. And now at this stage, we use the simple property of fraction over 5 to the k plus 1, and I multiply this by 5 to the k over absolute value of x to the k. Okay. And now, as again, ratio test, the like term together, so I'm going to have the limit of 5 to the k over 5 to the k plus 1 times x to the k plus 1 over absolute value of x. All right, let's see, this is equal to what? 5 to the k over 5 to the k plus 1. So this is going to leave me with 1 over 5, because as we said, this is nothing more than 5 to the k times 5. And here is the same, because this term could be split into absolute value of x to the k times the absolute value of x. So this would leave me with absolute value of x. So the limit disappeared because this has been totally simplified. And now, so that's what the ratio. So now the discussion. Basically, now we have to discuss what's really going on. What does the ratio test tell me? This r strictly less than 1. If I pick a value of x that make this quantity less than 1, then the series will converge. So now by the ratio test. Using the ratio test. Okay, if first, if 1 over 5, the ratio, is less than 1, then the series converge. Okay, but what does this mean? It means that if 1 over 5 times the absolute value less than 1, we need to find the values of x. So we need basically to isolate the absolute value. If absolute value is less than x, or x between -5 and 5, because they usually ask me about the interval, so I have to write this way. So the series converges. So we usually put those on a number line to make it clear. So on the number line, this is my number line here. Between -5 and 5, this is -5, and this is 5. This is 0. Right here, if I pick any x in between, if I pick x to be 1, 2, 3, 1.2, 1.3, 2.4, right here, the series converge inside. Okay. Now, by the ratio test, again, the series diverges if the ratio is larger than 1. It means x bigger than 1 or x less than -1. So it means right here, it diverges. We still have 2 points. So everything between -5 and 5, we know what happened. After 5, we know. Before -5, we know. We still have 2 points, -5 and 5. If x is 5, what's happening is, if x is 5, the ratio is 1. It means the ratio test is inconclusive. We have to figure out another way to find this out. If x is -5, also plug it here into the ratio, I get a 1. So at the end point, the ratio test means if I plug in 5 into the expression of the series, the ratio test will give me 1. So to find out what's happening at the end point, we have to use another test. So finally, we're going to take care end point. Okay. How do we do that? Okay. X equal to 5. What we do is we plug in the expression. We plug in the value 5 into the expression of the series. I mean the following. My series have the following term. That's the series over 5 to the k. My k going from 0 to infinity. I plug in 5 for x. That means whatever that is x here, I put in 5. So this would become -1 to the k times 5 to the k over 5 to the k. So I plug in 5 for x. When I do that, I will be left with -1 to the k. And now the question is, this new series, does this one converge or diverge? At this stage, this is a series of numbers. Does this converge or diverge? Any idea? What do you think? Does this one converge or diverge?
Diverge, because it would just go back between like
Diverge.
0 and yeah.
Because?
It wouldn't have a single number that it goes to.
It will not get close to any number. The 8 stands for what? When you tell me 8, what's the 8 here? Are you with me? I think you are. When you say 8, what do you mean by 8? What's the 8 here?
I don't know. I don't remember saying 8.
No, 8. You said it doesn't, right?
Oh, yes, the series. Sorry.
Okay, yeah. Because the series doesn't get close to any number. Why doesn't get close to any number? Because the series doesn't get close to any number. Close. All right, so let's see why your classmate is you can give me 2 reasons. Bryce, you are right. The terms don't get close to 0, or the series doesn't get close to any number. Both answers are correct. So I will put the parentheses to explain both of them. If I look at the series here, I'm going to explain 2 reasons why it doesn't converge from 0 to infinity. Let's see what the terms are. At 0, I have 1, minus 1, plus 1, minus 1, plus 1, minus 1, and so on. If I start evaluating the partial sums, let's see what happened to the partial sums. The first term, S1 is 1. S2 is 0, because I start adding. S3, 1 minus 1 plus 1 is 1. S4, 1 minus 1 is equal to 0. So if I evaluate the partial sums, I'm explaining both reasoning you guys gave me. So what your classmate told me, the series doesn't, because what's happening to the partial sum? S5 is equal to 1. So the partial sums, the limit of the partial sum doesn't exist. As your classmate said, it does not get close to anything. It's 1, 0, 1, 0, so it doesn't exist. So series diverge. Okay, absolutely correct. Now, another reason is what your classmate said, the terms in the series. So let me look at the terms in this series. Or you can say, what are the terms? The terms of the series are minus 1 to the k. These are the general term. And the limit is definitely doesn't exist, because the series are minus 1, 1, minus 1, 1, minus 1, 1. And the limit is definitely not 0. It doesn't even exist. So by the divergence test, series diverge. So both reasoning, either you look at the partial sum, because it's a fairly simple one, and you realize the partial sum don't get close to anything, it means the series diverge. Or you can look at the general term, and the general term don't get to 0. By divergence test, the series diverge. So this one diverges. Now if x equal minus 5, again, I have to check what's happening. So I plug in minus 5 into the term of the series over 5 to the k. Okay, and I would like to simplify this term. Sorry, this is x to the k first, and then I plug in minus 5. So you know where the minus 5 is coming from. Okay, so now, but how can I simplify the term? I mean, I don't want to keep it like this, because obviously there is a simplification. How can I simplify that? Minus 5 to the k. How can I write it? Anybody? I did that yesterday.
Negative 1 to the k times 5 to the k.
Right, it's negative 1 to the k times 5 to the k. Because if I simplify it like this, I can actually start working inside the series, because this is a bit messy, and we know something has to be simplified. So this is -1 to the k times -1 to the k times 5 to the k over 5 to the k. Okay. Now those will go away. Now -1 to the k times -1 to the k gives me what? Anybody? Any idea?
It would just be 1.
Yes, because. So this is 1. Honest to goodness 1. Okay, let's try it. And your classmate, another classmate, give me another good answer. Let's see why it is 1. If k is 1, it's -1 times -1. 1. If k is 2, 1 times 1, 1. If k is 3, minus minus. So this terms, -1 to the k, -1 to the k, one way you can look at it, as your classmate said, it's -1 to the power 2k. But -1 to the power 2k, it means basically that's an even number. -1 to an even number is going to give you exactly 1. Okay, so another way you can think of it is -1 to the power 2k. 2k is an even number. If you take -1 to an even number, you definitely get 1. So this finally will give me sigma. -1 times -1, it means sigma 1. Sigma 1 means 1 plus 1 plus 1, etc., which is, of course, diverges. So now a complete picture of the series. So that we have now the following series converges. So if this is my number line, is divergent at -5, divergent at 5, converges here, diverges here, and diverges here. So the series converge for x between -5 and 5, -5 and 5 not included, or on the interval, open interval, -5, 5. If I pick any value of x between those numbers, the series will converge. Okay. Now, a word, something called radius of convergence, because I'm sure some of the problem will ask you about the radius of convergence. The radius of convergence is basically, to remind us the radius of a circle, is basically the interval of convergence. You take the length of it and you divide it by 2. So basically that's called the radius. It's from 0 to 5. Okay, so 5 is called the radius of convergence. So one way you can think of it is you take the length of the interval of convergence, how long it is of convergence, and you divide it by 2. So in this case, the radius of convergence is equal to 5. Okay, so the rate, so basically in this problem, we said that the series converge on the interval centered at 0, that's the center of the interval, with radius 5. It means the center is 0, it's 5 to the right of 0, and 5 to the left of 0. And that's really the interval of convergence. So the radius is half the length of the interval. It's a number which is equal to 5. Okay, questions before I move on to your other question?
So the radius of convergence is 5, and the length of interval convergence is 5 divided by 2?
No. What's the length is how much do we have from here to here?
Oh, 10.
10. The radius is
5.
right?
Yes.
You should remind you the radius of a circle, because what's the radius of a circle? So that's the center, let us say, of the radius. That's the radius from here to here.
Yes.
Okay, so that's exactly the same. It's from the center of the interval to the edge, which is the same whether you take the left edge or the right edge. All right. Okay, so now let's look at number 29. I'll take another paper so I can do it all. Okay. So number 29. And let's see what this is. Number 29. All right. So it's sum of k square x to the 2k over k factorial. Okay. And the question is, that's a power series. Only even power are involved because I have 2k, but it doesn't really matter. And the question is, what value of x I can put here, and it will still guarantee that the series converges. So what values of x? So we use the ratio test. And we compute the usual thing. We compute AK, and we find an expression for AK plus 1. So AK is going to be a k squared x to the 2k over k factorial. A to the k plus 1 would be k plus 1 squared over k plus 1 factorial x to the power 2. And instead of k, I have to put k plus 1. And now I evaluate the ratio. Over AK. So it's the limit. So the question is which x I can put in of the following. K plus 1 square times x. That should be 2k plus 2. Do you think I'm going to need the absolute value here? What do you think?
No,
Because
doesn't seem like the absolute value will change anything
you're right, because
there's no -1 to the power of anything.
no,
So it wouldn't change.
no. Remember, x is a variable. The reason we put the absolute value is because not only because of the -1, because x could be negative. But what do you think is happening in this case?
You're
It's always
squaring
being
whatever
squared.
number you guess will always be positive.
Right, because. You're right. Just tell me because. Finish the sentence.
Because even if k is an odd number, it's multiplied by 2, so it'll be even.
Right, because this is an even number. So x to an even number is going to be positive, whether x is negative or positive. Okay, so the reason we put the absolute value, not because of the -1 to the k, we put it because that's one reason. The other reason is because of the x. So if I only have x to the k, this x could be negative. So that's why I need the absolute value. In this particular case, since the power is always even if I put the absolute value, the power is even. It doesn't really matter. It's going to be a positive number. So divided by AK. So when I divide by AK, basically I'm flipping those. Okay. And so now we do what we always do, put like term together. So k plus 1 square over k squared, because it's the same power, I can put them like that, make things easy for us. Then it's the k factorial over, now k plus 1, we've done this before, is k factorial multiplied by k plus 1. And finally, I have to the 2k plus 2 over x to the 2k. Okay, so the last step is really to simplify that expression. Now, x to the 2k plus 2 over x to the 2k, this will give me x squared because it's 2k plus 2 minus 2k. So it's going to give me the limit of k squared times 1 over k plus 1 times x. So this you can split this one, or this give me, think about it anywhere you want, that's 2k plus 2 minus 2k, so it's going to give me x squared. Okay, so now let us evaluate the limit. Equal to, when k goes to infinity, This term go to 0. Sorry, my apology. This term goes to 1. It's k plus 1 over k. This term goes to 0. And this is x squared. So this limit is going to be 0, which is less than 1. What does this mean? So what did I get? So I computed the ratio, and I realized that no matter what I plug in here for x, I'm getting a 0. What does this tell me?
All values for x would work and still converge.
Exactly. It means no, all values of x is work. No matter what value of x you're going to put in here, the series will converge. It means even if you put here 1,000,000 for x, the series will converge. You put any number you want, this series will converge regardless what x it is. Because of the ratio, so since r is equal to 0, is less than 1, regardless what x is, regardless what the value of x is, it means the series converges for all x's. Converge for all values of x. It means no matter what x is, the series is going to converge. So the series converge for all values of x. So in this case, the radius of convergence is, what do you think we're going to write?
Infinity.
Yeah, the radius of convergence is going to be equal to infinity. It means the series converge for all x's, no matter what it is. So regardless which value of x you put, the series will converge. So we have this series. I will put it here. So that is in x. My x can change values. But in this particular problem, it doesn't matter what x you put. The ratio test, so you put x equal 10, use the ratio test, it will converge. X equal 100, use the ratio test, you're going to get a 0, it will converge. It doesn't matter what x you put, the series will always converge. So before I move on to another idea, so this one converge for all x. So let me ask you the following question. So what can you say about those terms? If I look at the term, it means a single term. So if I look at those, what can we say about those when x goes to infinity? When x becomes very large, what do you think happened to terms like that? So if I just look at the term, what happened to them? If the series is convergent, no matter, because by the ratio test. So what can you say about those terms of the series?
They would go to 0, right?
Yeah, absolutely. They have to go to 0. If the series converge, it means the term will have to go to 0. They absolutely have to go to 0. So for example, if I plug in a specific value of x in here, so if this one converge for all x, so for example, in particular, let me take x to be 10. It means that if I plug in 10 here for x, and I use the ratio test, the series converge. But let us see what term I'm looking at, from 1 to infinity. It means I'm looking at the following term, 10 squared over 1 factorial, plus k equal to 2, 2 squared, 10 to the power 4 over 2 factorial, plus 2 to the power 3, 3 to the power 2, 10 to the power 6 over 3 factorial. And I'm adding those kind of terms. For k equal general k, I'm adding those kind of terms. That's the type of terms I'm adding. If this series converge, it means those terms become very, very small. Regardless what number I put here, k squared, x to k over k factorial are very, very, very small number. That's really that's one conclusion we can get out of that. Part two is
I have a question.
Yeah. of
Does that
course.
mean that all power series, when it goes to 0, does that mean it always converges for all numbers? Or is that just for that specific?
When the ratio goes to 0,
Okay.
right?
Mhm.
Now, if the terms go to 0, I have no idea.
Okay.
We know that when the terms goes to 0, I have no idea. This time, actually, I did the opposite. Because it converges, I said that go to 0.
Okay.
And that converge because the ratio test tells me to. Otherwise, I really don't know why this is going to converge. Only the ratio test is giving me that. So this time I'm going backward. Because it converges, hence the limit will have to be very small. And actually here, if what's happening is that k factorial, if this goes to 0, it means the denominator go to infinity way faster than the numerator. So with really, this is actually telling me that the factorial go to infinity faster than 10, than the exponential function. So even if I have 10 to the 2k, the k factorial goes to infinity way, way, way faster. So k factorial really grow very fast. That's really what's happening. If this goes to 0, it means this is growing faster than 10 to the 2k, way faster than that. I mean, k squared, we know 10 to the 2k grow faster than k squared. K factorial grow faster than the 10 to the 2k. So eventually it means if you take 10 to a highest, very high power, like 2000, divided by 1000 factorial, this is basically going to be small because 1000 factorial is going to be way higher than 10 to the power 2000 eventually. Okay, so k factorial really goes to infinity very, very fast. Right. The part 2 here is that all the power series I took in this problem are in X. It means they are polynomial in X to the k. Now, as I said yesterday, vaguely, that the idea of power series is going to, in a way, generalize the notion of Taylor polynomial. The Taylor polynomial could be in X, or it could be in X minus A. Means if I want to approximate near A, I need to use Taylor polynomial in X minus A. So now the question is, what if I have a power series where the term are not X to the k, X minus something to the k? How can I find the radius of convergence? So the principle is going to be basically the same, but before I do that, let me a little bit talk about the absolute value. So a simple problem. Suppose you're asked the following. So question. Okay, question. Find all values of X. So find all values of X. Such that absolute value X minus 3 is less than 10. Okay, so find all x's such that absolute X minus 3 is less than 10. What are the x's? First, let me see before any of you do any mistake with absolute value. We cannot split the absolute value if we have a sum or difference. It means absolute X minus 3 is not, so be very careful, is not absolute X minus 3. We can't split the absolute value if we have a difference between them. If we have a product, we can, but not a difference. And who can give me an example to convince me that this is false? Anybody give me any simple example? Who can give me a value of X to convince me that this is not, it doesn't work?
-2.
Okay, take X to be -2. So the first term will give me -2 minus 3, absolute value of -5, which is a 5. The second will give me absolute minus the absolute value of 3. It means 1 minus 3 is -1. So absolutely, I cannot split the absolute value, so we have to be very careful with that. So now the question is, for which values of X is x minus 3 less than 10. I want you to find the x's. Okay. Right, we will do like before. If the absolute value of something is less than 10, it means whatever we have, the x minus 3, is between 10 and minus 10. That's what it means. It means the maximum value x minus 3 can take is 10. The smallest value is minus 10. It means where is my x? I have to add 3 both sides. It's between 10 plus 3 and minus 10 plus 3. Okay. So it means graphically, I put 10 plus 3 on purpose because I want to show you where is my x, which means graphically the following. The highest value is 3 plus the 10. The smallest is 3 minus the 10. Means if I look at this at 3, the highest value is 3 plus 10. That's the 13 here. And the smallest value is 3, but you take away a 10. And that's going to give me minus 7. It means x between minus 7 and 13. But graphically, it means x is between 3 plus 10. It means it's this interval, and 3 minus the 10. So basically, the value of x satisfies this condition at all the x's in the interval, which is centered at 3, basically, and radius 10. So it's all the x's in the interval centered at 3 and radius 10. And geometrically, the absolute value tells you the distance between x and 3. It means all the x's whose distance to 3 is less than 10. So geometrically, this tells you represent the distance from x to 3. So absolute x minus 3 represent how far is x from 3. And this telling you the distance from x to 3 is less than 10. So all the x's will be those x's whose distance to 3 is less than 10. It means all the x's in the interval centered at 3 and with radius 10. So that's how you do it algebraically, but that's really what it means. So in general, so in general, suppose A is fixed number, and R is fixed. Okay. And the question is, find all values of x such that absolute value of x minus A is less than R. Okay, so that's the general condition. What are those x's? All right, I'm going to repeat the algebra and the geometry. If this is less than R, it means what's between here, x minus A, is between R and minus R. The maximum value is R, the minimum value of R. So it means where is my x? I add, it means A, add the R, A, take away the R. So graphically, where is my x? If this is my A, x is between A, you add R to it, and this will give me the A plus R, and you take away R from it. And this will give me A minus R. And this is where my x is, between A plus R and A minus R. It means the x is in the interval, centered at A as with radius R. That's algebraic. Geometrically, absolute value of x minus A is how far is x from A. And this telling you how far x from A is R. The maximum distance between x and A is R. If this is A, the maximum distance is R, it means my x has to be in here. So now with this in mind, let's go back to a power series, but this time my power series will be, instead of in x, we're going to take power series in x minus something, and we're going to ask the same type of question. For which x is the series converge? So example. Let me take the following series. Sigma. So the question is, find the interval of convergence. Of the following series, sigma of, let us say, square root of n x plus 6 to the power n over 8 to the n, or to the k, sorry. And k doesn't really matter. And my k, I'm going to let it go from 0 to infinity. So it's a series in x. And again, x vary. X could be positive, x could be negative. And my question is, which x's I can allow here that make the series converge? And we're going to use the ratio test. So using the ratio test, we have to find AK and AK plus 1. So what is AK? Square root of k over 8 to the k. And the AK plus 1 is the square root of k plus 1 over 8 to the k plus 1 times x plus 6 to the k plus 1. And now again, I do the same thing. I take the limit of the ratio, absolute value of AK plus 1 over the absolute value of AK. Now here, I have to take the absolute value because k is not an even power. K could be 1, 2, 3, and x could be negative. So x could be -7. And if x is -7, -7 plus is -1 is not a positive number. So here, the absolute value are necessary for x plus 6. I'm going to have here square root of k plus 1 times x plus 6 could be negative, so I have to take an absolute value, divided by a to the k plus 1, divided by ak. So when I divide by ak, I basically multiply by 8 to the k over the square root of k times the absolute value of x plus 6 to the power k. So as real life things are repetitive, the only change is going to be the x plus 6 in this problem. So now I put the like term together. I will have square root of k plus 1 over the square root of k times 8 to the k over 8 to the k plus 1 times x plus 6 to the k plus 1 over x plus 6 to the k. So I simplify and then I find the limit. Now, since I know I want to find the limit, it's nice to put this whole thing under the same square root. Now, 8 to the k plus 1, as we've done several times, it's 8 to the k times 8. So now when I simplify, I will have 1 over 8 times. The same thing hold here. This is x plus 6 to the power k times the x plus 6. We split it this way. Now I can get rid of that and I will be left with x plus 6. Now I evaluate the limit and then I use the ratio test. So this is equal to, this will come close to 1. And this is 1 over 8. So I will be left with 1 over 8 absolute value of x plus 6. So the ratio is equal to that. And now the ratio test tells me every x that makes this ratio less than 1 will make the series converge. So that's when we start using the ratio test. So now the series converges for. So the series converge when 1 over 8, that's when it converges. 1 over 8. Absolute value of x plus 6 is less than 1. Now, if I want the interval of conversion, it means I want the x value. It means on which interval this converge. It means basically I need to solve for the x. Which x's satisfy this condition? So we first we isolate the x, the absolute value term. So this will give me the x plus 6. I multiply by 8 both sides is strictly less than 8. Now what is my x? What is my x? Can anybody figure it out by themselves? Figure it out by yourself, just to make sure all of you can do it. Give me the x value. What is the x? And then we can draw them here.
From 2 to 14.
2 to 14. Kiana, right?
Yeah.
Yeah, I'm starting to know. Okay, tell me how you did it.
I did 8 minus 6 on one side to get 2.
Exactly.
And then 8 plus 6 on the other side.
Absolutely correct. So it means x plus 6, what's inside, as she said, is, she did it in her head immediately, between -8 and 8. It means my axis is in between 8 minus 6. And that's what you told me, Gianna, right? Whatever. -8 minus 6. It means my axis is in between -14 and 2. So graphically, where is my x? That's the minus. The center is always in the expression x minus a. The center of your interval is the a. That's really what the center of the interval is. So when you have x plus 6, the a is -6. So the center is actually -6 right here. So it's -6, you're adding 8. That's the 2. Sorry. And you're taking away the 8. That's the -14. Okay, so from here to here, it's 8. So the center is always the a in the x minus a. The a here is -6 because x plus 6 could be written x minus -6. So that's the a. So that's the center, which is at -6. And this is what we're going to call the radius. That's really the radius from the center to the edge, which is the length of the interval, 16 divided by 2, which is 8. All right. So the series converge between -14 and 2. Now the series diverge when the ratio is strictly bigger than 1. It means outside this interval. It means x larger than 2, x less than -14. So we have diverge here, diverge, and here diverge. And it converge inside. So usually the question would become right here and right here. Now, why we have a problem here? Because if x is -14, the ratio test is going to give me 1. So -14, to check what's happening at -14, the ratio test always will have to give me 1. So we have to try something else. So endpoint, that's the only thing we have left. Okay. So we have 2 endpoints, x equal to 2 and x equal -14. How do we check the endpoint? We take x equal to 2 and we plug it into the expression of the series. So that's my series. And I put 2 in it and ask myself, for this particular value, what happened? If I put 2 here, I have 8 to the k over 8 to the k. And this will leave me with the square root of k from 1 to infinity. Now, of course, here, square root of k is basically 1 plus the square root of 2 plus square root of 3 plus square root of 4 plus so on. So that's the series we get. And this one diverges by the divergence test. Because the terms don't go to 0. The terms, not the sum. Because the terms, which are the terms, it means the square root of k, that's what would mean the term, don't go to 0. So the terms are really actually here becoming very big. Now finally, we take x equal to 8, to -14. And we see what happened for that. Again, I plug in -14 for x. So this is x plus 6 to the k over 8 to the k. I plug in minus 14 in here. Minus 14, so I put minus 14 for this x. I'm gonna put minus 14. Minus 14 plus 6, that's minus 8 to the k over 8 to the k. And again, as we did before, minus 8 to the k could be split into minus 1 to the k, 8 to the k over 8 to the k. And finally, this would give me, those will simplify. This would give me sigma minus 1 to the k times the square root of k. Now, does the series converge or diverge? What do you think? So this will-
Diverge.
because, absolutely.
Alternating series test.
But what make it diverge?
Because it's not decreasing or it doesn't because it doesn't equal 0, the
Right.
limit.
Right, the limit of the term is not equal to 0. Absolutely correct. So this one diverges. Absolutely correct. Diverges because again the term, those terms, if you want the square root of k, you can concentrate on that. The limit is not 0. Okay, so even when the terms don't become small, period, the series is gonna diverge. So now the interval of convergence now. So interval of convergence is the interval of convergence. So the series converges for x between minus 14 and 2, or in interval notation, or on the interval open at minus 14 and open at 2. The radius of convergence. What's the radius of convergence in this problem?
8.
8. The radius is equal to 8. And the picture, we go back to the picture a little bit. It means this is the series. That's the interval of convergence. So it converges in the interval. That's how we sometimes we talk about it. Centered at minus 6 and with radius 8. So it converges in the interval. So minus 14, 2, that's really, for you, that's the answer, that's your down. But the way we understand this is in the interval. That's the center and that's the radius. So the radius is half the length from here to here is half of it. And that's my interval of convergence. So it's very much like we did when we had x series in x, not x minus a. The only difference will come really when you need to do the discussions. Instead of having x less than something, you're going to have x minus a less than something. You're basically translating the problem a little bit. There's some kind of a translation in this case. Okay, I definitely finish. I mean, this is on your exam as you expect. So for tomorrow, I will review with you. And I hope you guys started the review and you have questions. So come with questions from the review and I will answer every question you have about this section. Right? So class is dismissed. Anybody has any questions?